So some additional practice with the factoring method, just a few more things that you might see. So starting off with the steps, we want to simplify, rearrange, and remove any greatest common factors. This one doesn't have any of that needs to be done. If the quadratic is a trinomial, we're going to use that b squared minus 4ac. It is a trinomial, so I'm going to go ahead and do that. So my a here is 1, b is 7, and c is 6. So I'm going to plug that in as 7 squared minus 4 times 1 times 6. That gives me 25. That tells me that this is factorable and it has two solutions. So that gives me that piece of information. 25 is a square and it's greater than 0. Excuse me. So here, if it can be factored, we are going to factor it. So I have that x squared plus 7x plus 6 is equal to 0. I'm going to use the backwards FOIL method. So I need two numbers that multiply to equal 6 and add together to equal 7. And so I find 6 and 1. If I multiply that, I get 6. If I add it, I get 7. And that's what I'm going to split this middle term into. So I get x squared plus 6x plus x plus 6 equals 0. I'm going to go ahead and group these, pull up my greatest common factor. And factored, I have x plus 1 and I have x plus 6. Now that it's factored, I'm going to set each of these factors equal to 0 and solve. So I have x plus 1 is equal to 0 and x plus 6 is equal to 0. I'm going to subtract the 1 and I get x is negative 1. I'm going to subtract the 6 and I get x is negative 6. And so my final answer here, my parabolas are going to cross the x-axis at negative 6 and negative 1. Okay, number 2, same process again. Simplify, rearrange, check for greatest common factor. None of that needs to be done, but I do need to check that b squared minus 4ac. So a is 1, b is negative 6, c is 9. I get negative 6 squared minus 4 times 1 times 9, and I get 0. 0 tells me that this is factorable, but it also tells me that there is only one solution this time. So that's what I'm going to be looking for here. So I have x squared minus 6x plus 9 is equal to 0. I'm taking that and trading it out for a y with the 0. From here, I'm going to factor that. I need two numbers that multiply to equal 9 and add together to equal negative 6. So negative 3 and negative 3 multiply to give me 9. Add to give me negative 6. That's what I'm going to split this middle term into. So I have x squared minus 3x plus 9 is equal to 0. I'm going to go ahead and group those, take out my greatest common factor, and I end up with x minus 3 and x minus 3. Since my binomials are the same here, I only have to factor, or I only have to take one of those factors and set it equal to 0 because I'm going to get the same number either way. So I add the 3, and I get that x is 3. It's only going to cross that x-axis one time at the point 3, meaning the vertex is going to be there on the x-axis. Okay, number 3. So on this one, simplify, rearrange, or remove our greatest common factor. We notice that there is a greatest common factor here of 10x. So if I divide each of these terms by 10x, I'm left with x minus 9. And what I realize here is that my powers are 1. It's already been factored. So I'm going to take these factors and go ahead and set them equal to 0 and solve. So if I divide both terms by x, or by 10, I get 0 here. And if I add the 9 to both sides, I get 9. So here, my graph is going to cross the x-axis at 0 and at 9. Okay. On number 4, here's another example here. On this one, we do have a greatest common factor again, so we need to pull that out. So when I pull out the greatest common factor, I'm left with 2x squared plus 17x minus 30. Okay, and this trinomial is what I'm going to use to check that b squared minus 4ac. So my a is 2, my b is 17, and my c is negative 30. So I'm going to do 17 squared minus 4 times 2 times negative 30. And when I multiply all that out, I get 529. That tells me that this is factorable. It also tells me that it has two solutions. Okay, so I'm going to be factoring this. I'm looking for two numbers that multiply to equal negative 60 and add together to equal 17 to split that middle term into. All right, so from here, I have the 3 still as a greatest common factor out here. Then I have this trinomial, 2x squared plus 17x minus 30 equal to 0. This is what I'm going to be factoring here in the middle. So those two numbers, let's say 20 and negative 3. If I multiply those, give me negative 60. If I add them, they give me 17. So 3 is still out here. And then I have 2x squared plus 20x minus 3x minus 30. So I haven't forgotten about this 3. I'm just kind of leaving it out here. And then I have this grouped. I'm going to pull out these greatest common factors as a 2x. I'm left with x plus 10. I'm going to pull out negative 3. That leaves me with x plus 10. And so I have a 3, I have a 2x minus 3, and I have an x plus 10, all factors of this original trinomial. So I'm going to take each of those and set them equal to 0. So I have 3 equals 0, I have 2x minus 3 equals 0, and I have x plus 10 equals 0. And so when I do this, I notice that 3 does not equal 0, so that doesn't give me a solution. And I solve here, I add the 3, and I get 2x equals 3, I divide by 2, I get x equals 3 halves. And then over here I subtract the 10, and I get x equals negative 10. So these are my two solutions that I end up with, which is what I was looking for. So I have x is equal to negative 10 and 3 halves. And I can just leave it as a fraction. I don't need to try to put it in decimal form. All right, and the last practice example that we're going to go through is this number 5. So here we do simplify, rearrange, remove any greatest common factors. We don't have any of that to do. It's not a trinomial, so we want to check our factoring map to see if it fits any of the special types of binomials. And in this case it does. It has subtraction, the power is divisible by 2, and 25 and 1 are both squares. So this is a difference of squares. So I'm going to go ahead and factor it. I'm going to set it equal to 0, so 25x squared minus 1 equals 0. I know that when I factor this, it factors into two binomials. I take the square root here, I get 5x minus 1 and 5x plus 1. And so these become my two factors. And so now all that I have left to do is set my factors equal to 0 and solve. So I have 5x minus 1 is 0, 5x plus 1 is 0. I'm going to add the 1 and I get 5x is equal to 1 and divide by 5, x is 1/5. Here I'm going to subtract the 1, divide by the 5, and I get that x is equal to negative 1/5. And so that's going to be my factored answers here as negative 1/5 and positive 1/5. And that's kind of the basics for factoring them and using that as a method for solving your quadratics, for finding your x-intercepts.